With the number of vehicles on our roads steadily increasing, we have to focus our attention on their technical condition. Considering safety of all traffic participants, we first of all need to take a closer look at the wheel system. It is necessary that we inspect this system periodically. One of the elements to come under inspection should be the geometry of wheel alignment. To carry out this control, we need a properly equipped and fitted service workshop. The control stand should be arranged over the workshop spit or on a stable lift. The turntables and sliding plates, elements on which wheels will rest, should be on a level. Using GTO Laser device, one can easily carry out controls of front and rear wheel alignment in relation to the geometrical drive axis. The front measuring devices and their lasers are powered without any power leads by the inbuilt accumulators. All main elements of the GTO device are placed comfortably on the trolley. The wheeled trolley makes it easier to move around the diagnostic station. Before any tests, load the car according to the producer's recommendations so that we can reliably compare the results with the producer's standards. Before we begin any wheel alignment test, we should make sure of a number of things. First, make sure that the size of each tire and the wheel rim are the same. Also check if there is no excessive steering wheel play and that there is no excessive radial or face runout. Then check the tire pressure and the depth of the tire tread profile, as well as the condition of shock absorbers. Buckled wheels in which wheel flanges are deformed must be replaced. After carrying out these, install the clamping devices equipped with the special catches adapted to the shape of a wheel rim on each wheel of the car. While doing so, please pay special attention to that the catches are tightly fitted into the wheel rim. Put front and rear measuring devices on the clamps mandrels. Before the proper measurements are carried out, it is absolutely necessary to compensate the runout of the wheel rim and the clamping device system. The measurement results depend greatly on the accuracy of this activity. The compensation should begin with the rear axle. After lifting the whole car or only its rear axle wheels, loosen the locking screw at one of the rear sensor's bodies in such a way that you can turn the wheel without changing the sensor's position. Check whether the sign on the runout compensation handwheel coincides with the zero on the scale, and then lower the hinge screen, exposing the mirror. Set the measuring system to such a position that the laser ray reflected in the mirror falls on the symmetry screen of the front sensor. Slowly turn the tested wheel, observing the laser spot movement along the scale of the symmetry screen, and find the maximum and the minimum indications. Turn the runout compensation handwheel of the rear sensor by as many units as there are in the difference between the maximum and minimum indications. Turn the tested wheel until the minimum value is indicated by the laser spot on the symmetry screen scale. Next, turn the tested wheel to such a position that the point of wheel's maximum runout is at the bottom. That is, turn it through an angle of 90 degrees. Tighten the locking screw of the sensor's body. Having followed the same procedure for the second rear wheel, lower the rear axle of the car in such a way that the tested wheels are rested in the centers of the sliding plates. Press the car rear several times in order to achieve a proper position of the rear axle suspension. Before we begin the runout compensation of the front wheel axle, we should lock the steering wheel with the steering wheel blocking and pull the handbrake. While slowly turning the tested wheel, watch the laser spot movement on the hinge screen scale of the rear sensor and find maximum and minimum indications. From the zero position, turn the run-out compensation hand wheel by as many units as there are in the difference between the maximum and minimum indications. Turn the tested wheel until the minimum value is indicated by the laser spot on the hinge screen scale. Next, turn the tested wheel to such a position that the point of wheel's minimum runout is at the bottom, that is, turn it through an angle of 90 degrees. Tighten the locking screw of the sensor's body. Having followed the same procedure for the second front wheel, unlock the turntables and lower the front axle in such a way that the tested wheels are rested in the centers of the turntables. Press the car front several times in order to achieve a proper wheel's position on the unlocked turntables. Then unlock the steering wheel blocking and immobilize the car by applying the brake pedal depressor to the foot brake. The proper measurements begin with the control of rear wheel camber angles. Level the rear sensor by means of the level placed on the device body. With the use of the camber angle hand wheel, direct the air bubble of the mechanical module level to the central position. Read off the indication on the hand wheel scale, and this is the measured angle. Follow the same procedure for the second rear wheel to determine its camber angle. The second measurement to be carried out is the control of the individual rear wheel toe-in. Level all measuring sensors and turning the steering wheel leads to equal indications on the scales of both hinged screens. This is wheel setting for the straight-ahead driving in relation to the car symmetry axis. Now you can measure the individual toe-in for one of the rear wheels, for example the right one, with the use of the front and rear measuring devices placed on wheels on this side of the vehicle. Set the camber angle hand wheel and the toe-in hand wheel to the angle of 0 degrees. Lower the hinge screen, exposing the mirror of the rear measuring device. Set both toe-in hand wheels of the front sensors to achieve 0 degrees. Using the laser levers, direct the laser rate spot on the toe-in screen of the opposite device. Direct the laser spot to the central position by turning the outer toe-in hand wheel, which automatically causes turning of the inner toe-in hand wheel, and read off the indication by the hand wheel scale, which is the corrective value for the rear wheel. Set the hand wheel of the rear individual toe-in angle for the corrective value so as not to change the position of the camber angle hand wheel, which is set for the value of 0 degrees. Direct the laser spot to the central position on the symmetry screen by turning the camber hand wheel, which automatically causes turning of the individual toe-in hand wheel. Read off the value of the right rear individual toe-in angle on the individual toe-in hand wheel of the measuring sensor. Having followed the same procedure for the left side of the car, read off the corrective value for the individual toe-in for the left rear wheel. Based on read-off values, we can determine the total rear wheel toe-in and the difference between the geometrical drive axis and the axis of symmetry, the drive axis angle, the offset. If the result is equal to 0, this means that the geometrical drive axis is in line with the vehicle's symmetry axis. When the result is positive, the geometrical drive axis is deflected left from the symmetry axis. And when the result is negative, the geometrical drive axis is deflected right. The total rear wheel toe-in is determined as the sum of the rear wheel individual toe-ins. This way we defined all the parameters referring to the geometry of rear wheels. The front wheel measurements should start with the control of the caster angles. While carrying out this measurement, the mechanical module for vertical angles should be set perpendicular to the device's body. Check the front sensor's leveling and, having led to the straight-ahead driving position, set the angular scales of the turntables to an angle of 0 degree. Turn the front wheels until the turn of 20 degrees in is achieved by the tested wheel. With the camber angle handwheel, direct the air bubble of the level on the mechanical module for vertical angles to the central position. Set the caster angle handwheel to an angle of 0 degree, so as not to change the air bubble position and the level. Turn the front wheels in the opposite direction until the turn of 20 degrees out is achieved by the tested wheel. Turning the camber angle handwheel, which automatically causes turning of the caster angle handwheel, direct the level bubble to the central position. On the handwheel scale of the caster angle, read off the value which is the caster angle. The control of the camber angle is carried out with the wheels set to the straight-ahead driving position and after leveling the sensors with the body's level. With the camber angle handwheel, lead the air bubble of the mechanical module level for vertical angles to the central position and then read off the indication on the scale. This indication is the measured angle. The next angle which can be measured with the device is the kingpin inclination. In order to conduct this measurement, we need to set the mechanical module for vertical angles parallel to the device's body. Undo the knurled nut that is under the mechanical module and turn it through 90 degrees until the pull clicks and then tighten up the nut. Follow the same procedure as for controls of caster angles. Turn the front wheels until the turn of 20 degrees in is achieved by the tested wheel. Lead the air bubble of the mechanical module level for vertical angles to the central position. Set the caster kingpin angle handwheel to an angle of 0 degree. Turn the front wheels in the opposite direction until the turn of 20 degrees out is achieved by the tested wheel. Leading again the air bubble of the mechanical module level to the central position by simultaneous turning of both hand wheels allows for reading of the kingpin inclination on the caster kingpin hand wheel. Follow the same procedure to carry out measurements for the second front wheel and determine camber and both caster and kingpin inclination angles. Before we start control of the individual front wheel toe-in, we should first set the caster angle hand wheels of the rear sensors to an angle of 0 degree and then lower the hinge screens of the rear sensors so as to expose the mirrors. Turning the steering wheel leads to equal indications on the symmetry screen. This is straight ahead driving position in relation to the geometrical drive axis. After leveling of the front measuring sensors, check whether scales of both toe-in hand wheels have equal indications. By turning the outer toe-in hand wheel, direct the laser spot onto the opposite lying toe-in screen and set it to the center line. This will automatically cause turning of the inner hand wheel. On both scales, read off the value which is the value for the front rear wheel. Follow the same procedure for the other front wheel and read off the value by the toe-in hand wheel. Obtaining identical values for both wheels means that the tested vehicle has parallel axes and the read-off values are the individual toe-in angles for front wheels. If the indications are different, it means that the tested car does not have parallel axes and that the read-off indications are not the individual toe-ins. In this case, these parameters should be calculated from simple formulas. In order to calculate the front wheel total toe-in, we need to add the individual toe-ins. If, for example, we read off values minus 10 minutes on the outer toe-in hand wheel of the right device, and plus 30 minutes on the left device, we calculate the values of discussed parameters by substituting the read-off values to the formulas. Without changing the position of the outer toe-in hand wheels, turn the inner toe-in hand wheels on both devices in such a way that they indicate the calculated value of individual toe-in, Z. This activity is meant to ease the toe-in adjusting. This way, the indications by inner hand wheels are not influenced by setback angles. In such a case, when the Z value is not equal with the standard value for a given vehicle, turn the outer hand wheel along with the inner one in such a way that the inner hand wheel indicates the standard value. This will cause movement of laser spot on the toe-in screen. Adjusting, we should try to lead the laser spot back to the center line, bearing in mind that we should keep the straight ahead position of wheels in relation to the geometrical drive axis. After finishing the measurements, all devices' accessories should be put back on the trolley. Make sure that the front measuring sensors are properly placed there, so that the recharging process begins and the diode located on the accumulator's holder cap is signaling it. Please do not drive it to lead off the vehicle off the test stand. The vehicle should be rather pushed off the turntables and sliding plates. To ensure long life of the elements, it is advisable to lift the vehicle and remove them from under the wheels.